Everyone for joining us today to learn more about Apache Airflow on Microsoft Azure. I'm excited to introduce you to three guest speakers that we have today. The first is going to be Matthew Small, who is the head of solutions architecture at Bitnami. Matt works directly with Bitnami's customers, users, and partners in cloud platforms to bridge the gaps with awesome software from our application catalog and automation products from Bitnami. Next, we have Parikshit Savjani, who is the Senior Program Manager for Azure Open Source Databases. Parik focuses on making the experience for developers and database administrators of Postgres, MySQL, and MariaDB as simple and as powerful as can be on Azure. And lastly, we'll finish up with Patrick McClory, who is the CEO and founder of IntrospectData, which is a platform-first and open-source-oriented DevOps and data engineering firm specializing in strategic coaching and implementation of DevOps, data science practices, and AI and machine learning technology to future-focused organizations. We'll be having a Q&A session after the slides and demos are completed, but we encourage you to send us your questions throughout the presentation in the Zoom Q&A panel that you'll find in the right corner. And I will save all of the questions until Q&A and present them to the speakers to answer. And now I'll hand it off to Matt Small to get started.
Great, thank you, Miranda. Appreciate the introductions. Hello, good morning, good afternoon, and good evening, depending on where you are in the world. Really appreciate you spending some time with us today to learn more about Apache Airflow. In today's conversation, we're going to be giving you just an introduction to Bitnami. We'll be going over some Airflow 101, talking about some of the basics and concepts of Apache Airflow. You're going to learn how easy it is and see a live demonstration of launching that multi-tier Apache Airflow using Azure Resource Manager templates and leveraging first-party Azure Database services such as Postgres and Redis. We're going to learn a bit more about some of the new features and capabilities from Azure around Postgres especially. We've got a great demonstration of some new features from Postgres from the command line. And then finally, Patrick will take us through some use cases for Airflow and where Airflow would fit in your architecture for your workflow requirements. And we'll get a live demo of using Airflow on Azure. As Miranda mentioned, we will do live Q&A at the end. Please do submit your questions as we go through. A quick introduction to Bitnami. Bitnami has been packaging software for cloud providers, enterprise IT organizations, service integrators, and managed service providers for over 10 years. We're core maintainers and leaders of numerous open source projects, in addition to the open source software like Airflow that we package and make available on Azure and other clouds and on other container platforms. We are a strategic partner to all the various clouds, and we do offer Airflow in multiple different formats. As a result, our applications are deployed over 1 million times a year and drive over 1 billion operational hours per year of use. And Bitnami maintains over 1,500 different image and deployment template artifacts to ensure that the things that you get from Bitnami are always secure and up to date. That include the latest open source software, as well as the latest system package updates and other hardening best practices. We support thousands of users and thousands of organizations in this, and we have a lot of different offerings from free to paid. I'm going to pass it over to Patrick here to talk a little bit about the Airflow 101.
Thanks, Matt. Again, everyone, this is Patrick McClory, IntrospectData. Do a little bit of just talking about Airflow here to introduce the concepts and level set. And I will be very open and say that Airflow is a product, or it's an open source tool set that can go very deep. We're going to stay pretty top level to do some orientation at this point. So as a project, it started in the engineering teams at Airbnb in October of 2014. It was open sourced a little over a year later. And from there, it then became an Apache project and has most recently become a top-level Apache Foundation project, which means it is sort of a primary first order project in their world, and it is here to stay. What is it at its core? It's a bunch of Python and Flask. If you're familiar with the Python toolset and Flask as a framework, this entire toolset is built off of those common open source frameworks. And the most generic way to talk about this is that as a toolset and as a set of components, it's a triggering mechanism to do stuff and an interface to manage it. There are some terms that we use. DAGs, directed acyclic graph, means a couple of things, but that is really the fundamental building block of Airflow, and that is the sort of task package that exists in the Airflow world. It is acyclic, which means that in this setup, we cannot have cyclical dependencies, which is, from a workflow perspective, something that we generally try to avoid as well, but it is intentionally calling that out as a no-no in this world. And again, the structure here is meant to take workflow into code and into components and make it as easy as possible to have as much depth as possible in what you can do with it. So when people ask me, what is it that Airflow can actually do for me? There's a can and a should answer here. It can do a lot of things. The operators, which are the individual task level components, they can do a lot of things. There are pre-built ones that make it easy to interact with databases, with file systems, with external systems. And then there are language level components, specifically easy ones like Bash scripting as well as Python scripting, which allow you to do essentially anything you want. And what's great about that is it's incredibly flexible, incredibly extensible. We'll show a very basic demo today, but you can see over on the right the list of built-in operators, and there are plenty of ways to extend that. So as we kind of go into what makes this unique, if we can go to the next slide, there are two things I want to call out as specifics. Actually, I went one too far. Apologies, Matt. The big deal here in my mind is that it starts to allow for some operational patterns that instead of going directly with a task managed, celery based kind of engineering heavy approach to doing workflow, you get a lot of value in being able to both sort of decouple the configuration and consumption of connections to these third-party or external systems. And in this respect, I'm thinking primarily about databases and connection strings and secrets and things that, as a developer, I don't necessarily need. I need a way to consume connections to a secure system. But if I can, as an administrator, as someone who's operating a system on the whole, offer that as a key-based connection instead of having to give you the connection string every time, all the better. And in fact, for developers, all the easier to develop against as well. So it allows for some great separation of duties and separation of concerns at that level. And then, to the point around the work that Bitnami does on this, by default, you're getting an RBAC-enabled setup with their templates here. And what's really important about that is that clearly we all are concerned about and aware of security needs in the world around data, but this begins the best practices approach as you start. It isn't a concern that you have to think about ahead of time. You aren't going to get a vanilla Airflow server with no configuration. They've already done quite a bit of work to push in some very common, sensible, and easy to agree with best practices, especially around security. So from there, I think we'll give it back to Matt and talk a little bit through the details of how to actually get a hold of this in Azure and what that looks like.
Great. Thank you, Patrick. What a great overview. Looking forward to your demo here. First, what I want to demonstrate is how to get your hands on this yourself. So as Patrick mentioned, Bitnami has created a templatized version of Airflow, multi-tier in nature, to allow you a quick and easy experience to get a best practices reference architecture set up with a lot of common architectural elements included, such as role-based access control and some default configurations to get started with your workflow project. The best way to get access to this is to go to the Azure Marketplace and just search for Airflow. The Bitnami one is going to come back on top. You can also actually just search Airflow from portal.azure.com, and you're going to see the Apache Airflow Multi-Tier from Bitnami there as well. What you're going to do is you're going to grab the template from the marketplace, and you're going to launch that through the Azure portal. For documentation and how to get started, including configuration of the application itself, as well as how to get started with your first workflows, Bitnami also publishes comprehensive documentation. Take a look at this Airflow blog post on Azure for more information about how this is configured and set up, and you can also get community support from the Bitnami forums for Airflow. Key features of this template are that it's simplified. It is a common reference architecture. For example, Postgres databases is the most common database attached to Airflow, and that's the default for Bitnami's Airflow template. We have synchronized volumes and have Git integration for those directed acrylic graph files, those DAG files that you'll see an example of, as well as some documentation and sample DAGs included to get you started. It is secure with role-based access. All the connections are over SSL, and public and private network configurations are available to run this with public access or behind your firewall. It is a distributed architecture, multi-tier in nature. We'll go over that in just a moment. And it does leverage Azure Data Services on the back end for redundancy, retention, durability, and disaster recovery options. This is also customizable. You can launch this and you can modify this directly once it's running in your Azure account. We can also deliver this to your specification. If you have specific requirements for operating systems, OS hardening process, or any other requirements for packaging software in your organization, we can certainly explore Bitnami's enterprise catalog version of Airflow for you to deliver that according to spec. At a high level, the architecture that we're going to look at today includes multiple worker nodes using the Celery executor. It includes a node scheduler to distribute work to those nodes. It includes a web server it got role-based access enabled that you will use to actually log in to Airflow. And it is connected to both an Azure cache for Redis as well as an Azure database for Postgres. Patrick will go into the architecture and flow in greater detail in a moment, so I'll leave that to him. And one of the core maintainers of Airflow just had this to say after testing, and I'll leave this with your thought before I show it to you myself, that Bitnami's removed the complexity of deploying the application so you can focus on building the actual workflows, starting from those DAGs. Data scientists can create a cluster for themselves in about 20 minutes on Azure, and you don't have to wait for DevOps or a data engineer to provision one for you. So you can consider this self-service Airflow. So let's take a look at a demo. And what we're going to start here is with the marketplace. Again, just search the marketplace for Airflow and you'll see this Apache Airflow Multi-Tier. You'll click this Get It Now button to get started with provisioning that into your account. That will present you with the Azure portal and begin the provisioning process of your ARM template. When we hit the Create button here, we'll be sent into our workflow. Now, as you can see, Bitnami has pre-selected a few deployment time parameters that you can helpfully set for yourself in order to purpose build this workflow deployment to your requirements. So for example, we'll call this live demo Airflow for our deployment name. We'll give this a password. And we can also set up our database connection information here as well. So again, I want to pass this a username and password here. I can specify the number of worker nodes that I require. As you can see, we can scale this thing out. These are, of course, are just suggestions here. I'm going to deploy it with the suggested 2. If you want to make this publicly available over the internet, you can select that here to allocate a public IP. We're going to go ahead and do that. And if we want to add this to a resource group, we can even create one new here. So we'll call this resource group Live Airflow. We'll deploy it into US East, and we'll hit OK. Now the next page here is to set up your instance access. Once you deploy those Airflow VMs, you will need to log into them in order to actually set up your DAG files and execute some workflows here. So we do need to pass a password into that as well, or of course you can supply a SSH key. As you can see, you can specify different VM sizing if you prefer for those instances as well. At this point, you get to some Postgres database configuration settings. Of course, I can pick any type of optimized tier that I would like coming from Azure Postgres, specifying the capacity and any retention policy or redundancy policies that I would like to include here. Of course, this is all the power of Azure Postgres, which you're going to see in more detail in just a moment from Parikshit. Oh, there's our Redis server as well. Again, same tiers that you can choose from for Azure Redis. We get to our summary. It will run its validation. That validation will say passed, and we will be ready to hit OK. At this point, we go into the purchasing phase where you're acknowledging that this will indeed cost you money when you hit create, but all of this is money that you're paying to Azure. This template, as a reminder, from Bitnami is free for you to use. That deployment will kick off here, and so we've submitted in our deployment. We'll now do a bit of a cooking show example here and show you what you end up with and what Patrick's is going to demo on today. That deployment will set you up a resource group. It will configure everything from virtual machines to disk images to shared volumes to Azure Postgres to all the networking configurations and all the storage accounts required to associate with it. So this complex multi-tier architecture is not only declaratively provisioned, but also stitched together into a functional way in order to get you started quickly. So with that, I'm going to pass this over. And we're going to hear a bit more about Azure's database service from Parikshit.
Thanks, Matt. Hi, everyone. This is Parikshit here. You can call me Parik as well. I'm one of the program managers here in Azure Data Engineering Group, focusing on managed open source databases, primarily PostgreSQL, MySQL, and MariaDB. So before we get started, I want to share and give you a perspective of how we in Azure Data Group are approaching the changing landscape of data platform around us. And before we do that, I wanted to share some insights and the data points which we used to make our decisions and how we are seeing the world changing. So in fact, what I'm sharing here on the screen and on the slides here is the data point from Stack Overflow. And this is insights as of 2018. They've also released a new insights as of 2019. But I wanted to use this as a baseline and a reference because that is the data which we also looked at. So one of the things which you see from this data point from Stack Overflow is PostgreSQL, or in general relational databases also, the popularity is still growing among developer community. With the evolution of NoSQL graph databases, there was a myth in the community and concern among the developers that, hey, is relational database dying? But what we're seeing as a trend among developers and even our enterprise customers, it is otherwise. Open source databases and relational database in general, the trend has been growing. Now, among the relational databases, if you choose, we have also seen a huge uptick on open source databases. So, which means developers naturally love open source databases, and they prefer open source databases wherever possible. And among the open source databases which are leading, the clear winner here is PostgreSQL. As you would see, it's a choice for millennial developers, as we learned about it. And to go a bit deeper in this data point is to understand why is that what we learned is Postgres being one of the extensible database out there, allowing you and catering to different scenarios. If you if you talk about geospatial workload and there is a post GIS extension, it makes it very suitable for geospatial kind of workload. In addition to that, Postgres has a data type called JSON-B, which makes it very preferred for NoSQL data store and NoSQL kind of scenarios. In addition to that, there is an extension called PLV8, which allows developers to run JavaScript code within the database engine. That makes JSON processing really easier. Besides that, the compatibility with Python and Ruby on Rails makes it really preferred for millennial developers who prefer these frameworks and for their applications. And if you see even the way Airflow is being developed, they prefer and they recommend using PostgreSQL and MySQL as a metadata store. And owing to its compatibility, Airflow, as Patrick mentioned, is based on Python stack. It's preferred by data scientists, and data scientists and the different patterns of the data which they want to analyze and even visualize. This is where Postgres is a right fit, also as a data store for data warehousing kind of workload. So this is the data point which we saw in the market, and this gave us the data to invest in these technologies. So 2 years back, we started working on managed services for these open source databases. Last March, we actually launched and GA'd our services, that is Azure Database for MySQL and Azure Database for PostgreSQL service. So with and last December, we also released Azure Database for MariaDB service. So with these data points, I want to share that how in Azure world, if you are a developer, what are the database options you have? So Matt, we can proceed to the next slide. So this is our strategy and vision, and while SQL Server is Microsoft's baby, it is 25-year-old product now, where we've invested a lot in the IP in the product itself. But when we saw the data points which Stack Overflow showed us, we also wanted to humble ourselves and embrace, and this was the right opportunity for us as Microsoft to exercise our growth mindset and to embrace the developer and the open source community out there and bring these open source databases on Azure platform. So with that vision and with that strategy in mind, we introduced MySQL and Postgres first last year, and in December we announced Azure Database for MariaDB service as well. So one of the key strategies we also want to keep in mind is we want to align and adhere with the community editions. So all these databases, open source databases, are community editions of the database. We do not want to fork it. We want to stay true to the community, and that is a principle which we are working on. So then the next question is, what are the differentiators with we as a cloud provider as a platform can provide for developers and customers who wants to run their application or workload on these databases. So the true value and differentiators which we want to provide is one is our manageability, and something which we have developed as we were working and bringing SQL database on Azure platform. So we reuse some of the same IP and some of the same concept, and this is how or this is the value which we provide for open source databases as well. So if you see our architecture for in Azure and how we provide built-in high availability, security, and intelligent performance. That's the core principles or the core differentiators which we provide on top of these databases and the value which this open source database provides on Azure. So the architecture and our design is we have separated compute and storage. So your compute or the binaries for PostgreSQL runs on a compute container, and this is not a Docker container. This is our proprietary container which we have developed on Azure platform, which runs the database engine. And your data files for the database runs on Azure storage. And by default, to maintain redundancy and to provide data protection, the data files are replicated 3 times at any given point in time on the storage. So what happens is if there is any kind of storage failure, we automatically spin up a new storage and replicate the data. So that is how we ensure your data is protected at all the times and you don't lose any data. Besides that, there is built-in backups, which runs like 24/7. We have full backups, differential backups, transactional log backups, which are constantly running, which ensures your data is, if there is any kind of corruption, if there is any kind of bug which you have encountered, or if there is any kind of oops error, and you want to recover your database and go back in time, you always have that option. In addition to that, if there is any kind of compute failure, then what happens is we automatically provision a new compute. And this is the beauty of separating a compute and storage. We automatically spin up a new compute, attach the storage, and connect it. So by means of a gateway, as you see on the screen, there is a gateway in the design. Gateway ensures that your application connection string remains the same. That is how we ensure it's a transparent application failover. Failover is an activity when we have to do patching, even during elastic scale up and scale down. So that is one of the another value prop when you're running your Postgres or open source databases on Azure is that if you want to scale up or scale down, it is just by just dragging the slider, and behind the scenes we provision a compute, a new compute with a higher vCores and memory, and attached to the storage, and that just simplifies it. So it's within a matter of seconds you can scale up, scale down, which is not possible in the traditional on-prem world. So these are some of the differentiators which we have developed. Now with PostgreSQL, one of the things which we want to again, and this aligns with our strategy and vision is, what we did was we recently acquired a company called Citus Data. Citus is an extension, or they provide an extension on PostgreSQL, which provides automatic sharding and scale out capabilities. And this is where, again, we want, rather than building or competing or challenging the open source community, we wanted to partner with them and go with the community. And we, in this case, it was fitting well with our strategy and principles. So we acquired Citus Data, and by means of that, we are now providing a scale out solution, an automatic sharding solution on Azure by just again, with seamless experience, where you can just click on the slider, move the slider, and you see a scale out solution. Having said that, Citus still continues to be as an open source extension. It is available for anyone to run it on-prem or even on other cloud providers. So we are not going to change that. That still continues to hold true. And some of the scenarios where Citus shines is multi-tenant SaaS applications, where you want to shard the database by tenant ID. That just happens automatically and transparently with Citus. It just takes care of it. Another scenarios where customers prefer to use Citus is real-time interactive analytics, IoT workload, where you want to make sure you capture the time series data, telemetry data, devices data, and at the same time, you want to run analytics queries on top of it while the data is still hot and being captured. So these are some of the scenarios where Citus shines, and we want to provide a managed service experience on top with Citus along with the community. So developers just have to write the code once, and they can deploy it wherever they want. So that's how we have approached open source databases on Azure, and in the context of Airflow, we have done the same. The choice for Bitnami and other customers to use PostgreSQL as a persistent store was very natural because it provides high availability. So in case of Airflow, PostgreSQL database stores the information, metadata information about your jobs, schedules, coordination between the worker nodes. All that is the persistent data which needs to be stored. So in case there are any VM failures, as you would know, when you're designing or developing on the cloud, you don't have to assume that everything is available 24/7. You have to plan and think about failures. You have to plan for failures. And it is important that the metadata store is persistent on a database which is available and protected. And that ensures that even if there is VM failures or compute failures, when the VMs or your worker node come back online, it automatically synchronizes with the database, understands with the job where the jobs are running, at what point they are running, and runs forward with it. So in the context of Airflow, and if you want to run Airflow on Azure, hosting a metadata store on Azure database for PostgreSQL was a natural choice for developers, for community. And with Bitnami templates, it just simplifies it. It just abstracts and takes that pain of deploying away from you. You just have to press few clicks, as Matt showed you, and it makes it really easy for developers to deploy Airflow and get started within few seconds or minutes. So I just want to quickly show a demo from a Postgres perspective. If you are a developer and if you want to provision a PostgreSQL database or give it a try, how would your experience look like if you've not tried this? Because this is one area which we are investing a lot to make an experience easy for developers. And I wanted to highlight and showcase the same. So as you would know, again, a Microsoft guy running Windows 10 machine, but running a bash shell here. We've invested on AZCLI, which is preferred and liked by the customers and community. So AZCLI is your interface or is your command line tool to develop or to script or to author any kind of content or interaction with Azure. So again, now we have simplified the experience. So if you have no idea, if you have no clue how to provision, this is the first time you're provisioning Postgres on Azure, then you can just start with a simple command, Azure AZ Postgres up. And what it will do behind the scenes is it will automatically create something called as resource group within the Azure. That is a default resource group it will create for you. If you're not familiar with resource group, it's a container where all the resources within Azure are hosted. And that is a layer of security and isolation for you. And within that resource group, a Postgres SQL server gets created with a name, with a system-generated name. And along with that, you will get a user ID and credentials as an administrator on that particular server, which allows you to create new users, create databases, and then use that databases and consume that databases through various applications and your preferred development framework or toolchain. So while this is getting created, it might take a few minutes to create. I just created an Azure PostgreSQL just before this demo. Or just before this presentation. So this is how your experience would look like. The server will get created, we'll create a sample database. We will ensure the firewall rule is in place so that by default, you need to whitelist your IP. That's to comply with the security. It is important for you to whitelist your IP. So we also do that automatically for you. And then there is a root user created and we grant all the permissions. Now, if you are a developer, you want to know that, okay, what is the connection string and how the connection string to my database looks like. So we also provide that. So depending upon whatever framework you're using, for for example, Patrick in his demo, he's going to showcase or show how he would use as a developer and query Postgres database. And for that, if he's using Python code, this is a connection string which he would use. Now, in Airflow, they have kind of parameterized it and simplified the experience using the UI. So it is a lot easier when you're interacting with the admin UI. But if you're developing just a code using Python framework, you can use this connection string. So this is going to be the server name if you want to use that, password and username. And it's needless to say, it's highly recommended you change the password the moment you log in. So this is the CLI experience which we provide. If you are comfortable with a portal or UI experience, we also have that in place. You can go to connection strings, and here you can see the same connection strings here. Again, some of the quick things which you can do. You can change some of the server parameters here from the portal. By default, we tend to be conservative at some places, being a managed service. Having said that, if you have experience on Postgres and you know what you're doing, you have the options to change the server parameters as well. And some of the differentiators and IP which we provide on top of community edition of PostgreSQL for developers is to make it easy to look into the performance. So we give query performance insights. So if you want to troubleshoot, if you want to know which queries are performing slow or fast, the long-running queries are listed here. You would see like queries, and you would also see the weight statistics, like how your weights are performing. In addition to that, we are also working on machine learning algorithms where if your CPUs are running hot, or if we identify a pattern which tends to slower your performance of the server, we want to give you automatically a recommendation. So this is your advisor or your personal assistant running and monitoring your Postgres server and giving you a recommendation that, you know what, I think you're running hot on CPU. You might want to tune your queries, or you might want to scale up. So in addition to that, from a security perspective, again, an IP which we developed initially for SQL, but we extended for the open source databases, is advanced threat protection. By just clicking this, which is available at no extra cost to customers, you are now protecting your servers from any anomalous threat which can happen. So if there is any out-of-bound connection, which is trying to access or hack your database, especially to protect you from SQL injections. So those things are available out of the box as a value and a differentiator from this service. So with that, I will pass it on to Patrick, who is an Airflow expert, to take you through the Airflow demo. Over to you, Patrick.
Thanks, Brick. Again, welcome back, guys. This is Patrick. I get to go have fun now. We get to talk about some of the detail and the guts of how Airflow works. So just to reorient, I want to come back and look at what Airflow looks like when it's deployed in a generic sense. Now, we have seen a little bit of the resource structure that comes out of the Bitnami templates. I've expanded that just slightly to highlight a few details here, but in general, what we'll do is we'll start on the front end and say that this setup, this deployment, it starts with a web server that talks to our metadata DB. Obviously, we're running Postgres here. There's a scheduler component that handles triggering and dealing with the execution or the kickoff of execution of tasks. And then in our case, we're using Celery. There are a number of what are called executors that do the work. And in this case, Celery, if you're familiar with Python and Celery and that ecosystem, Celery is enormously configurable. There are 100 different ways to deploy it, some great best practices that are out there. And one very key factor about how Airflow is developed and designed is that it delegates a lot of the sort of subsystem or dependency component configuration to that dependency's best practices. So in this case, using Celery, we would be able to tune and deal with Celery as if it were a normal install. Our Airflow setup consumes Celery, but if we had any particular architectural concerns, we could run a different type of broker or run a different type of result backend in Celery language. And in this case, I simply diagrammed it as a broker using RabbitMQ and a result backend using Redis, which is sort of the prototypical design. I believe our current setup is using Redis for both, but again, that's a configuration setting in Celery. That is not an Airflow specific setup. That again, to highlight the fact that these components are highly configurable. As you look at how you deploy Airflow or how you want to consume this type of service, you're going to be able to make a lot of choices, and we'll dig through a little bit of what that looks like here in a moment. But suffice to say, as a basic structure, this would be a very straightforward production deployment example if you're looking to understand the general scope of what it looks like. So let's dig in and look at what it actually looks like deployed. I'm going to go ahead and steal the screen here. And I'm going to start here in the Azure dashboard, just with the view that we left from Matt that shows here's the resource group that we created. This is our pre-baked version of it, showing 4 virtual machines. We have our database. We have an instance of Redis running, and it's all packaged up nicely, and it's set up and running. So I'm going to just tab my way over to the right and show you, well, at that point, we can identify what the public IP and public DNS name are, and we can click on the link, and we get to Airflow, and lo and behold, it works. So then the question is, now what? You get Airflow, and you wouldn't actually see a line in here with an existing DAG. You would see a very vanilla dashboard with nothing in it. So the now what question is that your first hurdle is getting your DAGs synchronized into Airflow. And Bitnami's done a great job of identifying how to do this. They've given some recommendations around, kind of cloning it from a Git repository. And in terms of Airflow, a lot of best practices revolve around treating these workflows as code and not simply as scripts. So the idea of using a repository to upload your scripts and your DAGs to them, and then that is a mechanism to synchronize them to all of the instances running your workflows, is a pretty straightforward, pretty common practice. Again, here you'll see, as Matt alluded to, the recommended workflow to do that, including using cron tab on a regular basis to automatically synchronize from your repository down. Obviously, this depends on having a repository that is publicly available at some level, or can be accessed via the public internet, even with keys if you wanted to secure this. But this is a pretty straightforward, pretty common setup for synchronizing workflows. With that, I'll actually come over to the demo code just to show what we have here. This is the DAG that we're going to demonstrate. And as a bit of background, I wanted to pick a common workflow, a common setup that I see a lot of customers sort of starting with in the enterprise world. And that's the idea of getting a file and doing something with it from a data level. And a lot of sort of subscription-based systems, data brokers, and the like will give you an SFTP site or an HTTP URL to get data from. There happens to be an open source project called GDELT. They build a very large database of all of the news events that happen globally, and they drop a new file every 15 minutes. And I thought that fit our sort of cyclical or time-based file capture and ETL workflow story closely enough. So what we have here is a pretty straightforward setup. And what we've done is we're using an HTTP hook and a Postgres hook. Hooks are what we'll see in the connections section in a moment inside of Airflow. We're also using the Postgres operator and the Python operator as the task wrappers, the actual tasks being run. And it's a very, very simple workflow. It is one step that we use the Postgres operator to create a table. And the table is very, very simple for our demo purposes. And what we literally do here is we give the task a name. We tell it what the SQL script is. We tell it what database to talk to. and then we give it the Postgres, connection ID. And that's the connection ID that we'll get out of the Airflow dashboard in a moment. And we assign it to the DAG that we created, and that's that. The next task is nearly as simple. We're using the Python operator. We give it an ID that is unique. We tell it that we want to provide the context, which is a dictionary of data that comes from Airflow. And then we tell it to call this function. And it's just that simple. You go write a Python function. I called it getGDeltData right here. And this guy goes and uses our HTTP hook, which is a wrapper around an HTTP request that we can pre-configure in the connection section. And we go and we get a file, we unzip it, we read it, because that file actually has the file that we need to go download in it. And then we go and download the file and push it into our database using the Postgres hook. We run insert commands with parameters that we capture from that file that we've downloaded and decompressed and downloaded the file within it. So again, this is sort of a simple go get a file, put it in the database workflow. I'm not looking to win any awards for most amazing demo here in terms of function and feature. I want to really talk about Airflow here, so I wanted to focus on the components there. So we are a bit unnaturally using the HTTP hook. It's sort of a silly use of it. The Postgres hook is a great use case. There are some bulk insert capabilities in there as well that, to keep it simple, we avoided. But again, as you get deeper into this, you'll find that using hooks and really looking at how you create connections and leverage their components is going to be very useful. Before we get back into Airflow, I want to very, very briefly tab through a few specifics. The Airflow documentation is excellent. There's a lot of great detail in their docs at airflow.apache.org. The quick start here, you can see it's very simple to get things moving. You can get it running in a couple of lines at the command line. I want to sort of identify a couple of specifics around executors as well. For this setup, we are using the Celery executor. For organizations that have different infrastructure biases, there are multiple types of executors. As a developer, I may run the local executor to kind of just keep myself running and do something simple. If I have a Kubernetes deployment in production, I may actually use the Kubernetes executor. And for most cases and in most setups, you should see those behave similarly one to the next. For those who do have Kubernetes who are in that world, I do see this kind of ability to put a task in a pod combined with more advanced usages of Prometheus or other monitoring and metric tool sets as a really interesting way to monitor the resource usage at a very, very detailed level when you're running these types of tasks. Airflow does a good job, but that could get to a point where it's nearly excellent. That's very deep into how this runs and executes. I wanted to show this primarily just to identify that this can go to a very complex setup and deployment beyond just the simple setup that we're showing today. Again, we mentioned it related to security. We are using sort of basic WebAuth today, but there are a number of options, including impersonation, in terms of how to authenticate users into Airflow. And I will not, even attempt to walk through all of the details here, but you can see it is extensive, and the options are both, very lengthy, but you will find that they follow along with Flask Security's basics and sort of the Flask security model that you would expect in a Python Flask application. So let's get into Airflow. So this is our silly little DAG that we wrote to download and persist GDELT data. You can see I made a bunch of nice little red error problems over here when we were deploying it initially. So I think that's a great opportunity to show the kind of top level status reporting. The big advantage here is that Airflow offers an opportunity to see at a top level very quickly how things are going, what's running, what was successful, what's failed, and then gives you a really large amount of detail as you click through. So I look down here into just looking at the detail of the DAG. You can see what's running, what's not. You can look at duration of tasks overall. You can identify, I think as a performance-minded engineer, I look at this and see kind of which parts of our process are taking the longest, and for large DAGs and large workflows, to identify the long-running tasks, the long pole in the process. They give you a lot of great tools here to go detail and find out what's wrong and kind of what's taking longer, what's not. Obviously, as we kind of dig through this, we can see different views and different sort of structural sort of visualizations of what's here. But as I click through, I actually get into a lot of very fine level detail related to logs and output of the DAG. And I was very verbose in making sure that all of my inserts logged out so that we would see that it is doing what it says it's doing. But again, this is a really easy way to provide great visibility to people who are either using these systems or are trying to develop against them. So 2 more things that I'll show you, and we can talk a little bit further, and we'll take Q&A. I know we're running a little slow here. If I go into admin connections, this is one of the areas that I think is very powerful from an engineering and an operations perspective. You can look at my GDELT PG-SQL connection ID. It's the name I gave it. The connection type is Postgres. We've given it the host. The login came from the output of that AZ Postgres up command. The password is not filled in because we don't want to change it at this point, but we could change the password that's signed, tell it the port, and we gave it even the SSL mode require parameter on the connection string. So this builds a connection inside of Airflow, and to punctuate it, to consume that, I call the Postgres hook and give it the PG-SQL connection ID. Now, I was standard Python developer at this point, and I abstracted that out into an environment variable and gave it a default. But you can see here, GDELT PG-SQL is my value since I'm not setting an environment variable. That's where we put the key, and it actually ends up going straight into this Postgres hook line. And that creates the connection string for us, and it means that I don't have to import any specifics or create a connection pool for myself in the code. So this both simplifies the developer's world, and it externalizes that configuration so that we don't have to be sort of sharing secrets for every workflow that we put through there. Similarly, I did a very similar, or kind of a very similar pattern for the HTTP connection. And again, this is a little contrived, but we're getting a file off of the data.gdeltproject.org domain, and you put the host and the schema in there, and when we make the request, we pass the path to the endpoint. This is primarily used for APIs. So again, you've got login and password. There are an enormous number of connection types in here. You can see we can connect to FTP, to everything from Docker registry to Postgres to Vertica. We've got SSH connections. You can connect to Azure Data Lake container instances and Cosmos. Again, the connection types here are numerous, and you have plenty of great options there. So, in terms of sort of separating those concerns, it's a really cool feature that is worth being aware of. Finally, the piece here that we showed a little screenshot of, but you can see, kind of directly is the 5 base roles that are pushed in via setting up RBAC in the security model. Out of the box, this deployment from Bitnami gives you, a great starting point for that. Obviously, there's a lot to tweak and play with as you work through the process of making it production ready for yourselves. But the structure is here. Adding and creating users is very, very simple. And if and when you further extend that to integrate with your existing, whether it's OAuth or it's your LDAP domain or it's Active Directory. This user role setup in here is both verbose, but it will be very familiar for people who have worked with Python admin interfaces, especially Python Flask interfaces previously. So from there, what I'll do is I'll say this, that for people looking to get started locally, I highly recommend looking at the Docker Compose template. We've published one on our public repositories on GitLab, and really look at that as a great way to start locally. It's a really well-contained, well set of containers. We borrowed it from someone else, so we aren't going to claim ownership of that structure. But as we get back to the slides here, I would say let's feel free to reach out to our team and look at our repo. The demo code URL is at the bottom there. But as you get started, I really would like to offer kind of 4 big, basic, simple sort of recommendations. One is to start simple. Start with something you know. Airflow can be very, very powerful, but it's easy to build complexity quickly, especially with the amount of freedom and flexibility you get with that Python operator. So start with something you know, move from there. I'd also say that for those who are familiar with workflow processes or have used workflow engines in the past, maybe even large-scale enterprise ones, that you should focus on outcomes, not the process. It may feel a little codey or a little down in the weeds at times, but the non-functional benefits related to managing these as code, to the tracking, tracing, and visibility mechanisms in Airflow, they shouldn't be ignored. They're very, very powerful once you get to know them. And remember that this doesn't have to be your only tool. It's a great capability, and for some of your work, it might be very useful. For other pieces of your enterprise, it may not be the most useful tool. I'd strongly recommend not trying to shove a square peg in a round hole. Airflow is great at a lot of data-driven structure processes, and especially that ETL workflow. It's not a data pipeline, or it is a data pipeline. It's not a data stream. It's not like Spark or even Kafka. In terms of how it manages data under the hood. So kind of third, be ready to get your hands dirty. If you're familiar with sort of Python, that's great. It's super helpful, but not necessary. Don't let that be the reason that you don't step into this. And then, again, back to that Docker Compose setup locally, and sort of our perspective at Introspect is to make it safe to fail, make it easy and safe, and low cost to fail. And using tools like Docker Compose locally make it very easy to wipe the slate clean and start again. And by reducing that cost of failure, we find that we move a lot faster in our development with our customers and our clients, and with the kinds of work that we do when it comes to systems like this. With that, I think I've got my time here. It is back to Matt.
Thank you, Patrick. Fantastic demo. Great introductory content for helping new users of Airflow. Appreciate your contributions here and the great publicly available demo. So in terms of next steps, everybody, you can certainly get access to the Bitnami ARM template in the Azure Marketplace to get your multi-tier Airflow provisioned. Also be on the lookout in their container app marketplace for a forthcoming Helm chart for deploying it readily in AKS. For example, to leverage some of the Kubernetes operators that Patrick highlighted today. To learn more about open source databases on Azure, there's a plethora of information available. Parik is also always happy to talk open source databases, and his contact information is there. And then finally, of course, to help you get started in your workflow or your AI/ML project, or if you're looking at strategies around implementing DevOps or modern engineering practices in your organization, Patrick's information is there as well, and you couldn't go to a better expert in the field. So with that, I want to thank you all for attending. We are going to open it up for some Q&A. We have had a couple questions come in, and Miranda will read those to us. Of course, if you have others, please feel free to submit those in the Q&A panel, and we'll answer those live now. If we do not get to your question, we will certainly be following up with you by email, both with a recording as well as any answers to unanswered questions.
Great, thank you, Matt. So one, Parik, I think this one is for you because it was sent during your example. But is there an Azure pipeline YAML file available for the example that you did?
Azure pipeline YAML file. Maybe I'm not sure about which product or service are we talking about here. Yeah, maybe if you can reach out offline to me, maybe I need more clarity on this. Or if you're on the call, you can also talk more about it.
Yeah, definitely. I'll connect both of you. And then for the other attendees that are here, if you have any other questions, you can put it in the Q&A panel, and we can answer those shortly. We have about a minute and a half left.
While people are doing that, just as Parik was talking, I did want to kind of reinforce something around Postgres that I think is really interesting, that from a data science perspective, Postgres is both considerably more flexible for the early sort of beginning work around discovery and data science, as and it's very solid and performant once you get to the production side. So it really plays well on both ends of the development cycle, from early discovery into sort of high scale production. And it's really why I tend to gravitate towards that, not just as a developer, but as someone who looks at how these systems behave long term in production. So it's I'm not going to say it's the golden ticket or a perfect match for all use cases, but it's definitely a tool set that I find to be a good fit for a lot of use cases because of that extensibility that he'd mentioned.
Great, thank you, Patrick. And then another question that came in, the solution, Matt, that you showed on Azure from Bitnami, is that free to use?
Great question. So yes, everything that you'll find in the Azure Marketplace from Bitnami, Airflow Multi-Tier, and other container images, VM images, and deployment templates are all free for you to use. You will, of course, pay for your resource consumption in Azure, and of course, that is selectable depending on the resource requirements for your project. But all the templates and the images, as well as the continuous updates to those that we continue to publish to the marketplace for updates to Airflow, system packages, addressing security vulnerabilities, that's all included from Bitnami and free for you to use.
Great, thank you, Matt, and actually perfect timing, so we're closing up here. As Matt said, we'll send you all a recording of this webinar, and you're welcome to get in touch with us at any of those links provided here, or to Bitnami at enterprise@bitnami.com. Thank you again for joining, and